Assalamu alaikum. I am Dr. Faizullah, and in this lecture we shall talk about the Cauchy integral theorem and Cauchy integral formula. So let us start from the Cauchy integral theorem. Look at the statement. From the statement we can see that if we have some curve C, which is a simple closed curve, and f of z is any analytic function at all points on and inside the closed curve C, and f dash is some continuous function at all points on and inside the curve C, then that integral is equal to 0. So if we look at the statement of this theorem, first of all we need a simple closed curve. So we can use the Cauchy integral theorem only if the curve C is a simple closed curve. So what do we mean by a simple closed curve? Let us show you something from the whiteboard. Now from the whiteboard you can see that this is a circle and this is a simple closed curve. This is also a curve and it is called a simple closed curve. Now again you can see this is a closed curve in the form of a square or rectangle, and it is a simple closed curve. But you can see in this curve, this is self-intersecting curve. So this curve is not a simple closed curve. Now you can see from here, this is another curve. This curve intersects itself at 2 points. So that is why this is not called a simple closed curve. Similarly, if we see to this curve touches itself at this point. So this is closed, but this is not a simple closed curve. And again, of course, you can see this is a straight line and this is not a closed curve. So for the Cauchy integral theorem, first of all, we need a simple closed curve of these form. So if we have a simple closed curve, then we need another condition. The other condition, you can see that the function which is given in the integral must be analytic. What do we mean by an analytic function? So any differentiable function in a domain D is called an analytic function. So we have to show that f of z is an analytic function. The second condition is that the derivative of that function must also be continuous. So if all these conditions are satisfied, then we don't need to evaluate the integral. The value of that integral must be equal to 0. Now I will show you a generalized form of this theorem, which is basically called the Cauchy-Gorsa theorem. By the Cauchy-Gorsa theorem, we just eliminate the second condition. We don't need f dash of z to be continuous, because if f of z is analytic, then its derivative, its second derivative, and so on, all must be continuous. So by the Cauchy-Gorsa theorem, we only need a simple closed curve, and then we need that the function must be analytic. So if these conditions are satisfied, then the value of the given integral is equal to 0. And now let us show you some guidelines that how we can handle the problems, questions, or examples. So the first guideline which I would like to give you, that in the question, in the example, first of all you must be given a closed curve. So just draw the curve. Just draw. You don't need a pure sketch. Just draw a simple and approximate sketch of the curve. The second one is that if the function f of z, which is given in the question, is not in fraction form, then just show that this is analytic. And what you have to show that the function f of z is analytic, there are two types. Or show that the function is differentiable in the given domain, or show that the function satisfies the Cauchy-Riemann equation. So if the function satisfies the Cauchy-Riemann equation, then again the function is an analytic function. The second one is the third one, which is that if the function f of z is in fraction form, then what we have to do? In that case, we have to find the poles of the function. And we have to show that there is no pole inside the closed curve or on the closed curve. Because what is a polar singularity? Polar singularities are those points at which the function is not analytic. So if the function is not analytic, we cannot use the Cauchy integral formula. So we have to find the poles of the function f of z, and we have to show that all the poles lie outside from our closed curve. And now I have to show you, and we have to solve some questions, like let us see this example. In this example, you can see that we are given a simple function. F of z is equal to z square. So we have to use the guideline number 2 in this case. And now look at this function. In this example, the function is in fraction form, and we have to just find the roots of the function in the denominator. We have to find that z square plus 2z plus 5 equal to 0. We have to put this equal to 0, and we have to find the roots. And then we have to show that the roots lie outside of our closed curve. And in that case, the value of the Cauchy, by the Cauchy integral equation, the value must be equal to 0. So let us solve the first one. So we have to solve the first question, and look at the whiteboard. Now, from the given question, we are given, in this question we are given that f of z is equal to z square. And in the question we are given that the curve C is a circle. So it is given that z absolute is equal to 1. So first of all, we have to find the radius and the center of the curve. So from this we can write the radius. The radius in this case is equal to 1. And to find the center, we have to put this z equal to 0, and we have to solve this thing. So if this is equal to 0 plus 0 iota, which is equal to 0 comma 0. So now we have to draw this closed curve. So now this is our imaginary axis. Imaginary of z is this axis, and real, this is the real of z. Real of z, this is equal to x. Real of z is equal to x, and imaginary of z is equal to y. Now the center of this curve is the origin, 0, 0. And the radius of this curve is 1. So let this is 1, this point is 1, this point is 1, and this point is 1. So we have to draw a curve of the form like this one, which is a circle. So now we have to show that the function f of z is analytic inside this simple closed curve. Now to show that if it is analytic, we have to differentiate the given function. So if we differentiate the given function, we get that f of z is equal to 2z. Now if I put any point which is inside or on this closed curve, if I put any point here, we can see that f dash of z exists, or it is defined. So this implies that f dash of z exists for all z belongs to our closed curve C. So in this case, we can say that f of z is differentiable for all z belongs to the given curve C, and any differentiable function is called analytic. So this implies f of z is analytic. And this implies that by the Cauchy integral theorem, integration of z square dz is equal to 0 along the given simple closed curve. This is one method to find that the function is analytic, but now I have to show you another method in which we have to show that the given curve satisfies the Cauchy-Riemann equation. So from the given function f of z, which is equal to z square and z is equal to x plus iota y whole square. So we have to just expand this thing. We get x square minus y square and plus iota 2xy. In this case now u is equal to x square minus y square and v is equal to 2xy. Let this is equation number 1 and this is equation number 2. Now to show that this curve satisfies the CR equations, we have to find the partial differentiation of u with respect to x, which is equal to 2x. And from this curve we have to find the partial differentiation of v with respect to y, which is equal to 2x. So from this we can see that ux is equal to vy. So the first CR equation is satisfied. Now again from 1 we can find, just differentiate this with respect to y and we get minus 2y. And now differentiate v with respect to x and you will get that this is equal to 2y. And from these two equations we can see that uy is equal to minus vx. So the second condition or the second equation is satisfied. So we can say that the given curve is analytic, and hence again by the CIT this integral is equal to 0. Now let us solve another example. In the other example you can see, example number 2, you can see that the function is in fraction form. So if the function is in fraction form, then what do we need? We have to just find the roots of z square plus 2z plus 5. So let us do that. Now we have to, and in this case you can see that the given closed curve is of the form z plus 1 is equal to 1. So again we have to find the radius. The radius in this case is equal to 1, and now we have to find the center. So for the center we have to put this thing equal to 0 and we have to solve this equation, which is equal to minus 1 plus 0 iota, and we can write that this is minus 1 comma 0. So now we have to just draw this simple closed curve. To draw the simple closed curve, we have to draw its center. Its center is minus 1 comma 0. So the center actually lies here. This is minus 1 comma 0. And again its radius is 1. So we have to find that it is a circle, center at this point, and its radius is 1. So let us draw a circle. It will be a circle like this one. So now in the next step we have to find the roots of z square plus 2z plus 5. So let us see, z square plus 2z plus 5 is equal to 0. And now we are using the quadratic formula. So we have minus 2 plus minus 2 square, which is 4, minus 4ac, which is 20, under the root divided by 2a, which is equal to 2. So let us just simplify this thing. 2 plus minus, this is minus 16, under the root divided by 2, and from this we can get 2 plus minus 4 iota divided by 2, and this is equal to minus 1 plus minus 2 iota. So we have now 2 points. The first point is minus 1 plus 2 iota, which is equal to minus 1 comma 2, and the second point is minus 1 minus 2 iota. Minus 1 minus 2 iota mean that this is equal to minus 1 comma minus 2. Now we have to draw these 2 points on the given closed curve. So minus 1, x is minus 1, which is this point, and y is 2. So this is 1, this one is 2. So this point lies at this point. So this is actually minus 1 comma 2, and we can see that this point is outside of our curve. Now let us draw another point. The other point is minus 1, x is again minus 1, y is minus 2. So this will be lie here. This is minus 2. So this point must lie here. This point is minus 1 comma minus 2. And now you can see that we have the poles which lie outside of our given curve. So we can say that by the Cauchy integral theorem, this is equal to 0. So we can say that since all the poles are outside of C, therefore by the Cauchy integral theorem, integration of the given question, which is z plus 4 divided by z square plus 2z plus 2z and plus 5 into dz, this is equal to 0. So this is the required solution. Again, I have to revise that if you remember these guidelines, then there will be no problem for you to solve any type of question by using the Cauchy integral formula. So now let us show you some other questions. Let us start from this one. How we can solve this problem? This is in this question you can see that the function is in fraction. So we have to find the root z plus 1 equal to 0, and from this we can get that z is equal to minus 1. And then we have to show that minus 1 lies outside of the circle or the closed curve, which is given z absolute is equal to 1 over 2. Like this one, you can see from the slide. Let us find the pole. So the pole in this case is minus 1, and it does not lie inside or on the closed curve C. So that is why by the Cauchy integral theorem, this is equal to 0. Now let us show you another example. Again, this is in fraction, so we have to find the poles, but also we have to draw the sphere. The sphere has vertices 1 plus iota, 2 plus iota, comma 2 plus 2 iota, and 1 plus 2 iota. So first of all, in this example, let us show you that in this example, first of all, you have to construct or you have to draw the given closed curve. So to draw the curve, let us see this thing. Now this one is x-axis, this one is y-axis, and this is x prime. So now the first one is 1 plus iota, which is 1 comma 1. So x is 1 and y is also 1. So the point lies here. This is the point which is 1 comma 1 or 1 plus 1 iota. Now the second point is 2 plus iota, which is 2 comma 1. So now x is, okay, no, this is minus 1, so we have to draw on the other side. This is actually minus 1. So we have to draw 1 comma 1 here. This is plus 1. X is also plus 1, y is also plus 1. So in that case, the point is here. This is the point where x is 1 and y is also 1. And now we have to draw 2 plus iota. 2 plus iota means x is 2. So this is 2 and y is again 1. So this point lies here. This is the point which is 2 comma 1. And now we have to draw the second point, which is 2 plus 2 iota. X is 2 and y is also 2. So x is also 2 and y, this is y is equal to 2. So this point lies almost at this point. This is 2 comma 2. And now let us draw the last one, which is 1 plus 2 iota. X is 1 and y is 2. So this point is almost here. This is 2, okay, this is 1 comma 2. Now if I connect these points, I will get this closed curve, which is a square. So first of all, we have to construct the simple closed curve, and then we have to find the roots. So for the roots, just put this thing equal to 0, and from this you will get that z is equal to minus 2 and z is equal to plus minus 2 iota. Now if you draw these points on the given square, you will see that these point lies outside of our closed curve, and that is why by the Cauchy integral theorem it is equal to 0. And now I will give you some exercise. So by using the concept of this lecture, you can solve all of these questions. So in our next lecture, we shall talk about the Cauchy integral formula. So till then, Allah Hafiz, Assalamu alaikum.